Hello and a very warm welcome on behalf of NTI Audio. Thank you for joining us for today's webinar. Today I want to present you some hints and tips regarding sound system troubleshooting. But let me please first introduce myself. My name is Markus Becker and I'm assisted today by Thomas Hupp, our technical director, who is also a very skilled and experienced live sound engineer. The topics that we have prepared for you start with an overview on a typical setup and typical applications. We will then dig a little bit into possible reasons why there might be no sound or a bad sound at the output of your sound system. We will take a look at the verification of the signal path, and I will introduce to you a new feature, the so-called fast frequency response. The major part of this webinar will be covered by the practical presentation that we have prepared for you. After that, I will briefly summarize the key issues that we have covered, and at the very end, I will take a look at the questions that have popped in and possibly add some additional comments. I expect that the overall duration of this presentation will be in the range of about half an hour. The sound systems we are talking about can be typically found for live sound events, be it temporary installations or concert halls or theaters, etc. Another typical application would be PA, public address installations, where you want to broadcast spoken announcements or also music through a loudspeaker system. This could be, for instance, in a congress center, in a university, a shopping mall, whatever. When we look at the typical components of such a test setup, we will see that it typically has a microphone or a music instrument, which is connected to the mixing console. From there we have a normally pretty long and thick multi-core cable, possibly even with a patch panel in between, leading to the sound controller or crossover stage. From there we are driving the amplifier, and the amplifier is connected to the loudspeakers of our system. Well, what can go wrong in such a system? The first potential flaw could be the connection between the microphone and the mixing console. Then the settings of the various electronic devices can cause troubles, can be the reason for any problem we are encountering. And last but not least, the cable connections, the connectors themselves, are a frequent cause of problems in our system. Now, what reasons are we facing when we have, for instance, no sound at all? You have established your system, you switch it on, and you don't hear anything. What can be the reason? A very trivial one would be that you have pressed the mute button at any point in the whole signal path. Another one would be that the microphone you're using is not powered properly. It's missing the phantom power, for instance. Another reason could be buried in the cable connection, either because the cable is just disconnected, or we are facing a broken wire or a bad solder joint, or we have a faulty pinning in the connector. All these problems may occur and can cause a missing sound in your setup. Then we have a couple of reasons for bad sound quality. One of them would be a defective device that is causing audible distortions in your system. Another one would be that you have improper settings. So you have an overload of the input stage, for instance, which is causing clipping in your system. So you will have, of course, aside of the distortions, you will realize a bad frequency response. Or another cause could be the hum appearing in your system, or feedback frequencies which are caused by a resonance effect between the sound that is replayed from the microphone. Well, what can we do? It is essential that we verify the signal path from the source to the final loudspeaker, to the whole system. So one problem we can face here at this picture, which is based, by the way, has been taken in a real place, in a real studio here in Liechtenstein, where we have the server room with some crossovers, amplifiers, whatever kind of electronic instruments, a lot of cables leading to the mixing console in the control room of that studio. And here you possibly have to face the problem that you have an open wire, you have an open cable, you don't really exactly know where it will end. So you have to identify the connection that you have established. And for that purpose, we recommend to use a unique test signal that you feed into the one side of the cable, and then by listening to the other end, you can identify the correct cable connection. Then the cable itself, the connection it provides, is it broken or is it working properly? For that purpose, we are offering a cable test that I'm going to show you in a minute. And of course, also the status of the device to which the cable is connected has a major role, a major impact on the proper operation. For that purpose, we are offering an impedance measurement that provides some interesting and essential information, or you can also execute a symmetry analysis of the signal, which also gives you some hint on the status of your system. Now I have to switch a little bit to a different topic, but I want to present that to you before we gonna show it to you, and that is this new feature called fast frequency response. Well, in a conventional test instrument, you would proceed as follows. You would generate a pink noise signal. Pink noise by itself is a stochastic signal, which has a flat frequency response over the logarithmic axis, but this flat frequency response is only noticeable over a long time period. If you take a short glimpse at the pink noise signal, you will not see the flat frequency response immediately. I'm going to show you that in practice just in a moment. So when you measure the pink noise signal, for instance, with the XL2 analyzer, you will see that there are major fluctuations. These bars are jumping up and down. So you will see generally there is a flat frequency response, but in reality, if you want to look at the specific frequency, you might encounter the problem because it's going up and down. Well, the XL2 is measuring continuously. That's what we call gliding measurement. And it is weighting these measurements it is acquiring in an exponential way. That means that the most recent measurement results will be weighted higher than the results that have passed a little bit time ago. So the youngest results are the most important ones for the overall result of the XL2. But if you want to get a stable result from a pink noise signal, you have to average over a certain time to get this stable situation. So here the correctly flat frequency response will only show up over a longer integration period. The new approach we are presenting is called the fast frequency response. Here we are generating a generic pink noise signal, which has a very special characteristic. It provides a flat frequency response within 1 or 4 seconds. It is up to you to decide which of these two signals you want to use. So you have already the flat frequency response within 1 second. And consequently, when you measure this signal with the XL2, again in a gliding way, you will already receive a very stable, very flat response within these 1 or 4 seconds observation period. So this is a big advantage to get a quick and accurate view and feedback from the incoming signal. I'm going to show you that also in comparison during my practical presentation. Well, here we are at the point of our practical presentation. Well, we have here a microphone, we have a mixing console, we have a crossover, below is the amplifier, we have connected a loudspeaker to the amplifier, and as test instruments we have the EMA Pro and here the analyzer, the XL2. The EMA Pro and the XL2 are connected to the controller PC via USB so that you will be able to watch the screen content of these two devices right away. So I just have to close this one here. Now you can see it here on top, the screen content of the EMA Pro and below of the XL2. Let us start with the features that the EMA Pro is providing. First of all, I want to show you that this microphone, which is connected to the mixing console, apparently is not yet working, because when I create a sound here, you do not see any reaction here on this LEDs, on the level LEDs. The picture is a little bit small, but you will see now if I disconnect the microphone and I'm using the EMA Pro instead as signal source, now immediately you see we have a clear signal at the mixing console. So the cable seems to be working fine, the mixing console as well, but something is missing to let the microphone create a signal. And the answer is quite simple. I have forgotten to activate the phantom power. And you can see that here, by the way, on the left bottom corner of the EMA Pro, now I see the 48 volt from the phantom power. If I switch it off, this voltage goes down to 0. So this value here, this measurement value, indicates you the presence of phantom power or not. So now I'm gonna reconnect my cable to the microphone. And now as soon as I create a noise, you see it on the mixing console that the system is working fine. So that was the first step to make my system working. Well, the next one is that when I reconnect my EMA Pro to the second channel of the mixing console, I replay this pink noise signal. Actually, this speaker here gives me a sound, but the second one, you don't see it, it's a little bit further aside, is dead. So apparently only half of the output from the mixing console is arriving at the speakers. How can we verify that? Well, here we have to take a look at the cable connection. And for that purpose, I'm going to disconnect the cable here from the mixing console and plug it to my EMA Pro, because I want to find out whether this cable is working fine or not. Well, let us assume that the other end of the cable is far away, not like on this place here. So I want to show you how you still can test the cable. First of all, you activate the cable test, and then you use this remote cable test plug, which I connect to the other end of the cable. And by unmuting the EMA Pro, you see here's the result. Sorry, I selected the wrong feature. This is the right one. So now the EMA Pro gives me the feedback. Pin 2 of this cable is open, so there is apparently a disconnected pin. So this cable is useless for our purpose, and I'm going to replace it now with another cable that I have already prepared. Which is working fine. Now, what I want to do still is I want to take a look at the impedance of my crossover. And for that purpose, I connect this new well-working cable to my EMA Pro and I activate the impedance measurement. Now here we see something interesting. On one side, we have the 18 kilo ohm, which is an indication that the crossover, the input stage is working fine, but we also have this asymmetry here. You see between pin 2 and 3, the indicator is very much on the right-hand side. It should be in the middle. So there's apparently something strange with this input impedance, and we may have a closer look on this feature by just moving the cursor here to this R2. And now you see input pins 2 has an impedance of 18 kilo ohm, input pin 3 more than 25. Well, when we noticed this asymmetry, we took a closer look at the schematics of this crossover, and we realized that it is intentional. The designer of this device has intentionally made it this way for different reasons. So in this case, it is fine, but it could also be an indication that something is wrong with the input stage. So having now verified this connection, I want to show you briefly the whole signal path with this signal, this unique signal identification that I mentioned before. And for that purpose, I activate the messages. And I'm going to replay that message via the loudspeaker so that you can listen what's happening now.
Ladies and gentlemen, this voice is a test signal to enable our engineers to adjust the audio system.
I hope you could hear it, but by replaying the signal, you realize that it is actually the correct cable that is connected to my loudspeaker. And now in the next stage, I can also verify the distortion of my signal path. And for that purpose, I select the sine signal, and I connect the XL2 to the output of my crossover. And furthermore, I will change the measurement function to this one. I unmute. And now you see we have an input level of minus 12 dBu. We have a more or less good THD. You see we are creating a signal at 100 Hertz that is measured down here as well. So this seems to be quite right now. But let me get back to the other function that I wanted to show you, the spectral analysis. And for that purpose, I'm going to now switch back to the file replay, but not the message, but instead the previously mentioned fast pink. Here you see now on the XL2 screen the shape, the frequency response of the incoming signal. And as soon as I change the crossover frequency, you see immediately and very smoothly the result, the effect on your screen. So this is a nice example how directly this frequency response is shown on the XL2. And I want to show you even that in a little bit more detail. And for that purpose, I'm going to directly connect the XL2 to my MR Pro. And in parallel, I will activate a second XL2, which I have also here sitting on my desk. The right side XL2 is the conventional one. I have a separate MR2 system, the signal generator that is creating pink noise on the right-hand side, and on the left-hand side you see the new fast frequency response measurement. You see it's much more stable, it's much clearer, much easier to read out the actual results from this display compared to this a little bit nervous display here on the right-hand side with the conventional measurement method. That was basically the practical presentation that I want to present to you, and I will now go back to my slideshow. And provide you a brief summary of what I have shown to you. These are the features that are provided by the MR Pro that are very helpful for this debugging. We have the cable test that can be, by the way, also executed just by plugging the cable into the lower connector and here the upper one. I just only showed you the one with the remote plug, but you can do it also directly on the instrument. we have the phantom power measurement, we have the load impedance measurement, and the signal balance indicator that provide very essential information for analyzing the status of your system. And then on the XL2 side, we have this fast frequency response analysis. Suppose you are using this special signal that we are providing free of charge for the MR Pro. We can measure the distortion with the XL2 and also use the spectral analysis for the detection of hum or feedback frequencies. This is actually a screenshot of spectrum where we have hum. We see here the 50 Hertz peak, here the upper harmonics. So this measurement feature also provides very helpful information for your analysis. Well, I'm already at the end of my presentation. From my side, I hope I was able to answer most of your questions, and I would of course be happy to welcome you again at one of our future webinars, for which you will receive an invitation as usual. So thank you very much for your attention and have a good day. Thank you very much. Bye-bye.